This video follows figure 6.24 and deals with the standard error of a proportion. If we look at the data in column A, it represents whether a form out of a number of forms was correctly filled out or not. The 1 indicates a form correctly filled out, the 0 indicates a form that was not correctly filled out. There are that was Control-Shift down arrow, 80 using the count function, 80 forms in total. If I take the average of these 80 forms, equal average, and again Control-Shift down arrow, I see that 75% were correctly filled out. That means 60 of the forms were correctly filled out. Now, if I want the standard error of the number of forms correctly filled out, I can say simply that I want equal STDEV, and I'll make it P because the standard error of a proportion is assumed to be the standard error of a population value, and we'll assume that these 80 forms represent all possible forms. And again, Control-Shift down arrow, and I get a standard deviation of 0.43. Now, to find the standard error, I have to divide that standard deviation by the square root of the number of observations, or 80. And when I do that, I get 0.048412. I've taken that standard error directly from the raw data, directly from these data. But if I have a proportion, I can get the standard error of that proportion according to the formula in 6.15 on 212. The standard error of a proportion is equal to the square root of the proportion times 1 minus the proportion divided by the total number of observations. And in order to make this work, I believe I need to add 2 more parentheses, and when I hit enter, I get exactly the same thing that I got when I used the original set of data. So the point of this is that anytime a proportion is known, or a proportion can even be estimated, the standard error of the data that makes up that proportion can be found with this formula. It requires no more than the total number of observations and the proportion itself.